Hi, this is Jichuan Zhen with his CS590 final project presentation of HPH generation. I'm going to start from the intro to HPH, but I would not like to talk too much about the basic stuff like whether or not HPH is a Lagrangian expression or Euler expression. That's something that you can access through the course slide. Rather, I would like to talk more about some most important and crucial stuff that I find very important to my project. Essentially, what we are doing with ACE-PH has everything to do to compute the force of each particles in a water body like this. So for example, like here, this is a little picture that I grabbed from some paper. So you can see there's a bunch of particles right here. So let's just take one of them, all right? So each particle, how exactly it's going to move is going to dependent on the force it is receiving. And this force basically comes from three aspects. The first one is the gravity, which is the external right here, and the second one is the pressure. So the pressure force here basically it measures how much a particle is influenced by its neighbors. For example, like here, so let's see this particle, all right, and it has three neighbors, which means these three neighbors, they are having some sort of a pressure on this one, and this one as well. It is receiving pressure from these three. So for each particles, we're going to compute the pressure of this particle from its neighbors, and also for the viscosity. And basically, viscosity is what defines how easily particles is allowed to move away from another one, because we all know that between particles there's a force of viscosity. It's like a glue. It's a restrict a particle to move away from this one. So also we need to take that into consideration. So with that in mind, we immediately realize that the input of the program could be pretty easy. So for the external, we can make the gravity as a variable to be twitched. And for the pressure, we can use the mass, because the mass of a particle is basically what makes the pressure, right? It's so it comes from something like counter force between particles, and also viscosity. We use just a variable called viscosity. The higher the viscosity, the harder the particle move away from another, and higher the pressure, and yeah. So the output of the program is I expected to see the particles behave like water. So how my solution is, I have a struct of particle inside of which there's a position which defines where the particle is, the velocity defines how fast and in which direction it moves, and acceleration defines the acceleration of this particle. This acceleration is resolved from the force right here. So, and also we need to have some other variables like densities and pressures and the pressure, density and pressure is what we need to use to do the computation of pressure. And also we need to, I declared a radius right here to be used in the collision detection later. Also, there's another variable called next particle, which is a pointer of the particles, and I'm going to talk about it later. Also, I have another class called triangles because I want to, aside from SPH, I want to make some, collision detections between SPH particles and other objects. And the simplest form of an object is a triangle. So let's say if I have SPH collision work with a single triangle, I can just make this triangle into a very complicated object and make the particle collide with complicated object. So this is the class of my SPH. It basically defines how my SPH work, how to update everything, how to compute the force. Right, for example, like here, it has a number of particles, which keep tracking of the number of particles. And here, there's some variables of kernels and grid size and number of cells. These are basically, it has something to do with my SPH computation, but it's just some, optimization to make the program run faster. Yes. And I'm going to talk about it later, all right? So there's some input which I set. I mentioned gravity, mass, K, stand, density. So for aside from some a physical-based variable, there's also some input that we can twitch, but these are not variables have very obvious physical meaning. It's just some variables that we can twitch during the computation process. It's more to mathematical side, not to the physical side. Yes. So where was I? Yeah, so SPH, we have K, which is a variable that we can define on our own, and the viscosity. And also we have some other helper variables like time delta and some constant that I used in the poly6 function and spiky function that is very important in the pressure and density computation, which I'm going to talk about it later. Right. Also, I have for every in the SPH class, I have 3 vectors. For one of them holds all the triangles because I want to do some collision detection thing, and another vector that holds all the particles, right? And also I have another vector that is holding the first particle of every cell in the space. I'm going to talk about it later. It's just an optimization method. So inside of my SPH, I also have some public method. Some of them is, for example, like this. It's used to create initialized particles with certain positions. And also I have, for example, like here, it's poly6 functions that is used to compute density. Spiky is for the pressure, and viscous is used for compute the viscosity. Also, I have an update function that is called outside from the main, and inside of my update there's so for each frame in my update with my HPH object, I'm gonna call get first particle each cell, which is an optimization grid-based function that basically make the program runs faster. And also, and then after I have all the information of the particles, I call compute density and pressure, and with the density and pressure I compute the final force, and then I use this final force to update the particle position. So here's a brief summary of my process. So this is a grid that I used to speed up my program in a pretty proficient way, I would say. So it is not closely related to the HPH function, but it's just a function that separate the space into different cells, and inside of each cell I am going to create something like a linked list. For example, like here, the particles like here, it's going so if you remember in my particle struct, there's a next particle, right? The particle has next particle pointer, which is pointing to the next particle. So inside of my H cell, for each one of the particle is going to point to the next one, and this one is going to point to the next one. So with this function, with this method, it allows me to very conveniently and very fast to get the access of all the neighbors of the particles. So without using some vectors or arrays that is seriously undermine the speed of my project. Yes. So after I know where each particle is and where its neighbors are, I am going to compute the density, and then pressure, and then viscosity, and finally I get the force, and then I update the acceleration with the force, and I update the velocity with the acceleration. Yeah. And I update the position with the velocity. Yeah. That's basically how it works. So let's see some demos. So as you can see right here, my project basically focused on the generation method of HPH. I didn't do any shadings or color, and right now there's I remember it was something like 3,000 particles right there. It's not a lot because my program is run on the CPU side, so which makes it pretty slow, and also I can change the terrain right here. So and now you can see that the particles is getting a mess because I'm using a randomized function to change the position of the triangles right here. So that's what made the particles, flipping around out of order. But now after a while we can see a clear form, right? So it makes it look pretty much like it flows like waterfalls. Yeah. So I have another scene that basically shows the collision of the particles. Yes, the collision between particles and triangles. So I made a something like a ball, a sealed vessel that can hold particles. Yes. Yeah, we can make it a little bit bigger. So you can see as the vessels is holding, is trying to capture my particles, and yeah, I can use some input to make the vessels moving around left or right, up and down, sort of that. Yes. But I think I just realized there's a problem of my triangles is that it's just that the collisions between my particles and the triangles, they are slippery collisions, so which means there's no bouncing, and I think there's some improvement between this collision because I can make the slippery collisions between particles and triangles more I can make viscous variables of the triangle because like you can see right here, it's moving too smoothly. Like, I don't think normal water flows like that because, so let's say a water drop, it gets into the vessel, it would immediately slip out of the bottle, slip out of the vessel like it's a ball or something. Right? It's going to like slip for a distance, but it will stop like within a short time. I think there's still some improvement of this. So here the conclusion of my project I withdraw is first, at least I made something work. I made the SPH work. I think that's something probably not very remarkable, but at least something that I'm proud of myself to do. And the next thing is the problem, and there's a lot of problem with this project. First is the performance. So when I add the particles to a number of something like 3,000 or 4,000, the SPH could be very ugly. And also I didn't do shadings, and I also have some improvements in the collision parts, and there's a lot of other things to do. Also, originally I wanted to, also because of the performance problem, I cannot even check the another function of my project, which is the PCI. Yes, it's also another method that is trying to make the water flows more smoothly, more realistically, and just because if I turn that on, the FPS could drop to like single digit, and there's no way I can check everything with FPS like that. So if I could give a chance to do this project again, I definitely going to do it in the compute shaders, because I think that's what makes everything like much faster, and much better. Yes, and I think basically that's my final project. Hopefully you like it.